So, what is Hopper? Well, Hopper is a development environment, development ecosystem that's intended to target small devices. Small devices being like 8-bit CPUs like the 6502 or the Z80, or microcontrollers. For now, I've got the full system running on a little homebrew 6502 machine here. The 6502 machine is based on starting off with what Ben Eater had done and then adding a bit more to it. So yeah, it's got a PS2 keyboard driver, it's got an LCD driver, it's got a timer in it, it's got a serial port interface. And using the serial port interface, I can connect to my Windows computer, and that's what's on the main screen with a little flashing icon. So we're already inside the Hopper ecosystem. It has a console just like you'd expect from other ecosystems, so dir. We've got a source folder here. If we do a dir here, there's the source code for the editor, the source code for the compiler, the debugger. There's also a 6502 folder, which is the interesting one, and I have a hello programming in here. So we have an editor. Let's load up hello. There it is. And this editor is also written in Hopper. Of course it is. So there's our editor. And we've included the system library for the 6502, which tells it should target for the 6502. It's going to clear the screen. It's going to print something on the screen. So you could do something like manually do this. You could go source 6502 hello preprocess, run the preprocessor, first pass of the compiler, and then you can say compile it, and then you can optimize it, and then you can generate the code for the 6502 like that. And then we could run the Hopper monitor, and we could load that code. So that would be like load hello, and we could, and then so that uploaded that code in an Intel hex file format to the 6502 machine, which is running Hopper monitor. It's running the server version of Hopper monitor, and on the Windows machine I've got the client version. So, and then I can just run this, and there we go. It says cleared the screen, and it printed hello 1975. So that's sort of your usual way of developing for small devices, is all in the console, one step at a time. But in the Hopper environment, it's easier than that. So let's go back to the editor. Over here, I can build, and it's the same shortcut keys I'd use in Visual Studio. So if I build it, it does all those steps here for me, and it's targeted 6502. And then I can, after I've built, I can say start, launch the debugger. The editor has a blue title bar, the debugger has a green one so that you can tell the difference. And it has successfully uploaded my program, the Intel hex file, again to the 6502 machine. I can repeat that again if I turn it off, turn it on, and then if I go reload, it'll upload it to the device. So there it is. And now I can F5 like you would in Visual Studio, and it ran it, and there we have it again, hello world, hello 1975. Instead of doing that, my debug options are as you would expect in a real debugger. I can step into, step over, reload it. I can set a breakpoint here, and then I can F5 to the breakpoint. So now it has cleared the screen, but it hasn't printed yet. And if I F10, it's printed it. So let's see what else we can do with that. If we finish that, now we're ready to start again. Let's put a breakpoint here on the print statement, and let's F5 to there. So we've cleared the screen again, and we're sitting waiting to execute the print statement. Now, if I step into the print statement, a lot of the Hopper library is written in Hopper as well, so you can step through it. So we're inside the print statement, which is made up of a call to a print to pick your colors. Because on different LCDs, you might have the choice of colors. So we go into there, and now it goes into the colors file to go and find out what matrix green is, and this is a property, so it gets the color. Now it's getting the black color for the background. And we're back here, and we've printed the Hello 1975, but we're still on the same line. You can see the little cursor there. And then if I print this, if I go through that one, it'll move the cursor to the next line. So we've printed line, and we're back out again. So full debugging experience. We could make it a little more complicated. Let's go back to here. So we can make ourselves a variable I, which initializes by default to 0. We can make ourselves a loop. And we can say we want to print just the count of I, see what it is, to string like that, and then just increment I. And F7 to build that. It's compiled it, built it, ready, and then F5 to launch in the debugger, to upload it to the device again. I've cleared the screen. So if I just F5 this and run it, it should just be counting, and there it goes, it's counting up integers. If I Control C to break, stops in the debugger, and it's in the process of printing that string. So if I F10 back from there, I'm now here, I can see I is 281, which kind of jives with that, and then I can single step through here. So a full source level debugger for a language that looks a lot like C# or Java, in other words, a modern version of a sort of curly brace and semicolon language. The language has value types like integers and characters and bytes and booleans. It also has reference types built in. So it has dictionaries, lists, arrays, strings, and these reference types are managed by a heap manager with a garbage collector. So you don't allocate memory and free memory. It's basically a virtual machine like the Java virtual machine or the C# virtual machine, only it's running on an 8-bit machine with a full IDE and debugging experience. I'll do some other demos which explain these, and in fact I'll make a playlist which goes through the features of Hopper without getting too hung up about the environment we're currently working in. I hope you enjoyed that. Contact me directly if you're interested, and if you want to try and get this to work on your retro 6502 machine, I'd be interested in trying to get it work on a second machine. And that's all for now.